It's been about a year. I think it's about time we made part 2 of this series about how to make a soundproof studio room. Hiya folks, welcome back to the show. And if you remember, way back when we first started building this room, we knew that we were going to run into a few delays. We didn't know exactly how long those delays were going to be. We didn't think it would be a year. But yeah, we're finally at the stage where we can continue ploughing on building this soundproof studio room. We've had massive delays caused by various things. We're finally able to actually get hold of some cladding at a decent price, and we can actually get a lot of the stuff that's in here at the minute moved out so that we can finish all the internal stuff. So we're just about ready to start cladding it, but what I wanted to do was show you a few of the details before it's all covered up, because this is quite a key bit in the build. As per usual, this is just my approach to building this. I'm not saying it's the definitive way of doing it, but fingers crossed, I think it should work pretty well. Absolutely gorgeous spring morning, by the way, and I'm about to destroy the piece with an SDS drill. So just as a bit of a refresher of the construction of this is a double skin block and block construction. So it's a 300mm wall with a 100mm cavity. So 100mm block, 100mm full fill cavity, 100mm block. The general rule of thumb for soundproofing is density is your friend, hence going for the concrete block. It's then all going to be clad in red cedar, and fingers crossed, if that arrives today, it should look all awesome. Inside the room, ignore these lights. These lights are coming out, but we're going to be dropping the ceiling on genie clips to completely sonically isolate the ceiling from the rafters. It'll only be dropped by kind of 5mm or something, but it's basically making sure that the plasterboard doesn't physically touch the rafters. They're going to be on acoustic isolation pads. Above the ceiling there will be 100mm of rock wool acoustic insulation, and then we'll have a 50mm air gap to allow the free movement of air all the way from the soffits at that side all the way through to the soffits at that side. So obviously at the minute you can hear outside noises because effectively there is nothing between us and the outside other than like a 5mm thick piece of plastic soffit. Talking of soffits, the soffits are all installed, and what I've also done is I've fitted an acoustic batten above the soffits, where it's effectively a 18mm sheet of plywood with a kind of nub on the end, and that's to stop the insulation from being pushed too far and covering the soffit vents. The soffit vents are all covered with a mesh to stop insects from getting into the soffits, which it's unlikely that they would fit through that gap, but just to be on the safe side, it's all covered in a wire mesh on the inside. If you remember when I was constructing it, I fitted wall plates on the inside and outside, and a lot of you were wondering why, and it was simply, the ones on the outside was there simply to make it easy to attach this batten across the top. So this batten is completely treated with acoustic sealant behind it, under it, at the top of it, all around the door. Everywhere you see the white is acoustic sealant, so everything is completely sealed now. The only opening into the building is the vents on the soffits, and as I say, the ceiling's going to be acoustically isolated anyway, so there should be minimal noise getting through into the room itself. And remember, the main purpose of what I'm building here is it's effectively an editing suite, and where I'm doing voiceovers and things, so it's somewhere that I need to block noise from getting in as much as I need to block noise from getting out. As you can see, I'm just in the process of doing the battens for the cladding. On the front of the building we've got our acoustic glass window in. That took about 4 months to arrive, by the way. Everything about this project has been delay after delay, but yeah, we're finally, hopefully, going to get the outside of it finished. If needs be, we could add another secondary acoustic window on the inside and have it at a slight angle to this one, so you don't end up with standing waves building up between the glass. We'll see how it goes. We might be fine with that. It is very soundproof, that window. I think we're going to have other weak points that we're going to have to worry about a little bit more than that. The prime one being the doorway. There's going to be a secondary internal doorway, by the way. There's not just going to be a single door. What we've also done as well, and you can see all the little bits of white filler everywhere, that's acoustic filler. Basically, when we got this built, we're a bit naive to the whole bricklaying side of things, and the bricklayers who built this didn't bother to joint the outside of the building. So as a result, it was just full of little holes and areas where, you know, you could potentially get straight through to the cavity, and all those are weak points. And, you know, the odd little hole's not going to make that much difference, but across a building like this, it does all add up. So every single little gap and hole in the mortar, I've had to go around and fill with acoustic filler. Unfortunately, this was pre-Allen, and I think most decent bricklayers do joint all of the brickwork inside and out, but for whatever reason they thought that was too much hassle and didn't bother jointing the outside, whatever. So all I would say is, if you are getting a brickie to build something like this for you, make sure they properly joint the brickwork inside and out, because you want to make sure there's no little holes or anything like that in the mortar. Again, this top board here is screwed into the wall plate, the external wall plate at the top, and it's all acoustically sealed in. So we've got acoustic sealant all the way around the bottom, all the way around the top, every little gap. There is no way for sound to escape through these walls at all. The only potential weak points are the soffits at the front and back, because we've got to leave open ventilation since this is a cold roof, because we don't have the head height allowance to have a warm roof. On the back side of the building, by the way, because you're never going to see this, I've just used a bitumen kind of cladding material. I didn't want to go for a metal cladding in case any kind of weird resonance built up in it or anything like this. It's quite a rubbery material. Just got it from Wix. It's quite cheap and it's dead easy to fit. You just kind of screw it on. You should really use some caps to make the screw heads, to stop the screw heads from going all the way through, but to be honest, it's been fine. I do have some screw caps, I need to put them on, but so far there's not been any movement in this at all. It's nice and solid, it's nice and kind of acoustically absorbent, and as I say, no one can see this backside of the building anyway. So that pretty much takes care of the externals. And by the way, I'm not having any spotlights or anything in the overhang, as much as that would be lovely, but it's all going to be places where sound can potentially escape through. So we'll go for some wall lights. They'll look absolutely great. I just don't want to be digging into the soffits any more than absolutely necessary. So I've got a whole load of battens to fit, and then best part of 27 square meters of Western red cedar cladding. And a couple of days later, and our red cedar has finally arrived. Very, very excited. So we've got best part of 27 square meters of the red cedar here. I'll show you a little bit about that in a minute, because there's a couple of bits that are quite important depending on whether you're putting the cladding horizontally or vertically. We've also got all the corner trims here. These cost a fortune, but they're the last thing to go on. And just to show you our kind of starting point, all the battens are fitted, all screwed to the concrete walls, and that goes all the way around, all around the window area, all over the top there as well. And we're going to be fitting the cladding all the way down to the damp-proof course layer. So we're going to be installing this horizontally, and one thing that you need to get correct when you do this is getting the right profile on the wood to allow for a weather edge or a kind of drip edge on each board. So if you imagine each board is going to go vertically like that, and what you need to cater for on the profile is an angled section of wood just here. So this is really key if you're ever buying cedar or any sort of cladding really. If you're going to be installing it horizontally, you need to make sure you haven't got a right angle edge here. It's got to allow for runoff of rainwater. Slightly worryingly, quite a few bits have some quite major cracks in them. I'm sure it'll be absolutely fine. We'll have over-ordered and hopefully they've also oversupplied. We shall see. If we run out, we'll just have to return the broken bits and get some extra. Anyway, less natter, more cladding. So that's the externals pretty much completely finished. I used Osmo 420 UV protection oil on the cedar, and the door is painted in Zinza all coat anthracite grey. In hindsight, I'm in two minds whether we should have installed the cedar vertically instead of horizontally. We went for horizontal since it tends to disguise the height of the building a little bit. It just makes it look a little bit more squat, so it hopefully blends in with the surroundings a little bit better. I do think it looks good, but I feel like vertical would have been a bit easier. Plus we've had quite a few gaps opening up as the timber dries out. Easy enough to fix by just hammering the boards along, but it's one of those things that we could have avoided if we'd done full length vertical pieces. Let us know in the comments what your views are of vertical versus horizontal cladding. The door is simply a heavy duty fire door blank. I might add some acoustic treatment on the inside at some point, but I don't think it'll be needed. As I say, there'll be a secondary inner door anyway, and that'll also be a heavy duty fire door. I don't think that's going to be the weak point of the build. The biggest problem is going to be the soffits, but watch this space and we'll see how well the ceiling performs. By the way, the ceiling will be a sandwich of 15mm sound block plasterboard and Tech Sound acoustic membrane, all suspended from the genie clips I mentioned earlier. There will be 100mm of acoustic insulation over the top of that, so if everything goes according to plan, it should work pretty well, fingers crossed. As per usual, it'll be a few months until the next installment in this series, since I need to get the workshop moved into the garage and then I can start filming all of the internal works, but hopefully by next time we'll find out if this design has actually worked. So don't forget to hit subscribe, take care folks, and we shall see you next time. Tatty bye! Thank you.